Good afternoon, class. We are looking at the final exam review from 1.6 to 5.4. Here's the second part, and I want to remind everybody about the pledge. When you take the exam, in the beginning, it says, I pledge on my honor that I will neither give nor receive unauthorized assistance during the exam. Unauthorized actions include, but are not limited to, the use of the notes, text, graphing calculator, etc. In other words, imagine you take the exam in class. All right, so we're going to continue with the substitution method. Anytime we have a ln x, that's a choice of u. Its derivative is 1 over x. Therefore, it makes du is 1 over x dx. There are two formats. We rewrite this so it becomes clear. This is u squared, this is du. We use the power rule, and we get 1/3 u cubed plus a constant. Replace the u, and we are done. Again, bear in mind you have this posted. You don't have to write anything. Just sit back, relax, and make sure everything is coming back to you. A fractional format, you make sure you can simplify it first. Other than that, the denominator is a choice of u. And notice the derivative of the bottom is the top. E to the power of x itself, e to the power of minus x itself times -1. So du is the top times du, and you rewrite it in this format, which is the integral of du over u, following the integral of 1 over x dx is the natural log of x plus constant. That's what we get, and we replace the u. And because e to the power of x plus e to the power minus x is a positive value, you could change the absolute value to the parentheses. It's your choice. Notice I want to take the integration here, and the theta says theta is the independent variable. So 5 gives you 5 theta. Cosine gives you sine, so plus 2 sine theta and a constant. Anytime you have exponential, the exponent is a choice of you, everybody. The derivative is 5x to the power of 4, which makes the u 5x to the power of 4 dx. We are going to rewrite this so it becomes clear what is given and what is missing. As you can see, this is e to the power of u. This one is not du because number 5 is missing. Instead of solving for dx, because 5 is a number, we're going to throw in the 5 and its reciprocal 1/5. And now we have 1/5 the integral of e to the power of u du, which means I can get 1/5 e to the power of u and a constant, replace the u, and we are done. Replace the u, 1/5 e to the power of x to the power of 5 minus 2 plus a constant. And we are going to move on to the next question. All right, so what happens here is that you are dealing with a natural log, and that is always the choice of you. Having said that, the derivative is 1 over x plus 1 times 1, or simply 1 over x plus 1, which makes du is the same thing times dx. Let's rewrite this so it becomes clear. This is u and this is du as far as the limits are concerned. Of course, this gives you half of u squared. If I plug in 0 here, I get ln 1, which is 0. If I plug in 1 here, I get ln 2. And remember, in calculus, you always go with the exact answer, so replace it with ln 2. This doesn't do anything, so half of ln 2 quantity squared. What happens when you're dealing with the sinusoidal functions? If the argument is not just basic x, t, or theta, and it's a function of a dependent variable, independent variable, in this case, x squared, that is the choice of u. Its derivative is 2x, which makes du 2x dx. We are going to move the x next to dx. So it becomes clear everything is in order. Number 2 is missing. So we throw in 2 and it's reciprocal 1/2. So we write it as half of the integral of sine u du. Therefore, the integral negative cosine results in negative 1/2 cosine u and a constant. Replace the u and we are done. Now, what happens when you have both sine and cosine? The one that has the exponent is a choice of u without the exponent. Its derivative is cosine, which means du is cosine x dx. So we're going to write it as the integral of u squared du. Using the power rule, we get 1/3 u cubed plus a constant. Replace it, and we are done. So what happens when cosine has the exponent? Well, cosine is the choice of u, everybody. Because cosine has the exponent, cosine is the choice of u. Its derivative is negative sine, which makes du negative sine x dx. So we are going to notice that this doesn't have a negative sign. We're going to put a negative in, negative out. Their product is positive 1 because the reciprocal of negative 1 is itself. So having said that, we rewrite it as equals negative the integral of u to the power of 20 du using the power rule. This becomes 1/21 u to the power of 21 and a constant. Keep the negative sign, replace the u, and the final answer is negative 1/21 cosine to the power of 21x plus a constant. Application problem. Many fish grow in a way that is described by von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years, rounded to 1 decimal? So we use the accumulated change, the net change theorem. But before we do that, this, the moment you see rate in calculus refers to a derivative. So if the function is the L of x, if L of x represents capital L of x, represents the length of the fish at any age x, then the growth rate, this one, is its derivative, L prime of x or dl dx, and this is the initial value. So L prime or dl dx is 29 e to the power minus x centimeters per year, and L of 0 is 1 centimeter. So the amount of increase follows the fundamental theorem of calculus, the accumulated change. So the amount of increase is from 0 to 4, the integral of 0 to 4, and you integrate this one, of course, times dx. The answer is itself divided by -1 and becomes negative from 0 to 4. You plug in. When you plug in, although this is 1, this requires a calculator, and you put it in. And you write with a bunch of decimals. You remember L of 0 is 1. You have to add, and then it says 1 decimal. 4 next to it is 6, goes up to 5 becomes 29.5 centimeters. It's an approximation because this is an approximation to begin with. However, a second format is that instead of finding the increase, we find the equation which represents L of x. That means you're going to integrate this, and you already have the answer, but plus a constant with L of 0 being 1. In other words, this is the general solution, but this initial value will help us find the constant. So plug in negative 29 e to the power minus 0 plus the constant. E to the power minus 0, 0 makes no difference. It's e to the power of 0, which is 1. So this is 1. So we have negative 29 plus c equals 1, which obviously makes c 30. So that's the function at any given time x. L of x is negative 29 e to the power minus x plus 30. Therefore, after 4 years, replace the x with 4. And again, the advantage is that if you want how long the fish is after 5 years, 10 years, 7 years, just replace this number instead of going through the process of anti-differentiation or integration again and again. The distance in meters of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? That's the average velocity, total distance over total time when you have 2 points in time, everybody. And with that being the case, you want s of 4 minus s of 2 divided by 4 minus 2. S of 4, you plug in 4, 2 times 4 squared minus 5 times 4 plus 4d. Then minus plug in 2, 2 times 2 squared minus 5 times 2 plus 4d. And the bottom is 4 minus 2 or 2. Simplify, and you get 7 meters per second. Units of the numerator over the units of the denominator. What is the instantaneous velocity and acceleration of the object? What is the velocity and acceleration after 6 seconds? Instantaneous means differentiation or just 1 point in time. So as you know, v is s prime of t, the instantaneous. So differentiate this and you get 4t minus 5. After 6 seconds, 4 times 6, 24 minus 5 is 19 meters per second. Acceleration refers to higher derivative. Acceleration is the second derivative of the position function. A of t is v prime equals s double prime. Differentiate this again, which is 4. I'm going to discuss the unit in a moment. 4 is independent of t, so at any time t equals 6 or 5 or 4 makes no difference, still the same thing. But why is this meters per square second? Because a of t is dv dt. dv change in velocity meters per second over change in time seconds. This gives you meters per square second. When does the object reach the velocity of 31 meters per second? Set it equal to 31. Move the negative 5, make it positive. 36 divided by 4 gives you 9 seconds. Use differentials to approximate cube root of 63.5, reminding you delta y is f of x plus delta x minus f of x. And delta y is the rise along the curve, dy is the rise along the tangent line, and delta y can be approximated by dy, therefore f of x plus delta x can be approximated by f of x plus dy. So what is the function? You look at the operation. The operation is taking a cube root, so cube root of x. Also, we need a number. Choose an x to be a number close to 63.5 for which the cube root is easy to compute. Obviously 64 because the cube root of 64 is 4. Now, what is dx? The change between the two numbers, and it's negative 0.5. 63.5 minus 64 is negative 0.5, which means when you go through the process, this is less than this, meaning less than 4. Now, again, I want to remind you, just for the sake of argument, instead of 63.5, if we were interested in, let's say, cube root of 65, and then dx would be 65 minus 64, which is positive 1. So you want to be careful with the sign and so forth. So now f of x plus delta x is f of x, which we have. dy we don't have. We are going to find it by rewriting this as x to the power of 1. So f prime is 1/3 x to the power of 1/3 minus 1, which is negative 2/3, or 1/3 cube root of x quantity squared. What is dy? The same thing times dx. And so we're going to write this as cube root of x and write this as dx over 3 cube root of x quantity squared. We want cube root of 63.5, which means this, f of 63.5, which means f of 64 plus negative 0.5. That's the meaning of this. Which means now we're going to go with this and replace the x with 64, same thing here, and the x with negative 0.5. This is obviously 4, so is this one. This one, 4 squared is 16 times 3. The denominator is 48. The numerator, we're going to change it to a fraction because it's a complex fraction, 1/2 over 48. That means 1 over 2 times 48, or 96. And this makes it 3 and 95 over 96. You want to keep it as that unless they ask you for so many decimals. If they don't say how many decimals, you have to answer it in this form. And we're done. If we look at the calculator, you see that they are very close. So if I want to stop here, I have to change it to 6, the same thing here. That's how close they are. Now, the second method is the tangent line. Linearization refers to finding the tangent line, and you don't have to memorize any of them. Just go with the point slope. Y minus y1 equals n times x minus x of 1, which means we want the tangent line for the function f of x equals cube root of x at x equals 64. So if you want a tangent line, you need two things. You need a pair. If you plug in 64, you get 4. So 64, 4 is the pair x comma y. You need the slope, and here's the derivative, f prime of x. If I put 64 here, I get 4 squared. 16 times 3 is 48, 1 over 48. Y minus y1 equals m times x minus x of 1. That means y minus 4 equals 148. X minus x of 1 is x minus 64. If you go through the process, and I leave it for you to do that, here's L of x. Now, if you plug in 63.5, put 63.5 over 48, then multiply by 2 to get rid of the decimal, and this becomes 96, and this becomes 127. And if you add them up, you get exactly this number. So they will give you the same answer. Very straightforward. Find the absolute max and mean for the function f, where f of x is x to the power of 4 minus 18x squared, the closed interval of minus 4 to 1. When you have a function which is continuous in a closed interval, you can use the closed interval methodology. First, you have to justify why you can use that. That means, is this function continuous? And the answer is yes. Why? it's a polynomial of degree 4, which makes it continuous from negative to positive infinity, and therefore it's continuous in the given interval of negative 4 to 1. Now we are ready to move on with the methodology to find critical points. First, we have to find f prime of x, which is what? 4x cubed minus 36x. Since we want to set it equal to 0, we are to find the critical points, we are going to factor the 4x out, we get x squared minus 9. We're going to factor x squared minus 9, we get x plus 3x minus 3. To set this equal to 0 results in x being 0, x being negative 3, x being positive 3, giving us 3 different answers. F prime does not exist, does not produce any solution. This is an empty set. This is phi representing an empty set. Why is that? Because f prime itself is a polynomial of degree 3. It exists everywhere. The domain is all real numbers. So with that being the case, there are 3 answers. Is 0 in between? Yes. Negative 3 in between? Yes. 3 is larger than 1 and it's out. So only these 2 numbers can be used. We are going to go to the third step, which says find f of a, f of b, f of c1, f of c2. So plug in the endpoints as well as the critical points. So you use this function, we plug in negative 4, we get negative 4 to the power of 4, minus 18 times negative 4 squared. We get 256 minus 288, giving us negative 32. Now this is all elementary algebra, basic math you're evaluating. Plug in negative 3, you get 81 minus 18 times 9, and you get minus 81. If you plug in 0, I hope you see that you get 0. If you plug in 1 to the power of 4 minus 18, 1 squared, that means 1 minus 18 or negative 70. So we have all of the above. Absolute max is the largest value. 0 is the largest value because the other ones are negative. Absolute max is 0 at this pair. Absolute minimum is the smallest value, which is negative 81 at this pair. This is the way I like to write it. But you write accordingly the way they give you, therefore you can get full credit. Absolute max is 0 at 0, 0. Absolute minimum is minus 81 at negative 3, comma, negative 81. How do you evaluate an integral, a definite integral, when it requires substitution? 2 different ways. First of all, this x is a polynomial, 25 minus x squared, not the square root. 25 minus x squared is a polynomial. 25 minus x squared is more complicated. That is the choice of u. The derivative is negative 2x, which makes du negative 2x dx. Move things around so it becomes clear everything is fine except negative 2 is missing. Because it's a number, you can throw in negative 2 and do it with its reciprocal and rewrite it in this fashion. I'm going to stick with you, and notice I didn't put the limits because I'm going to get back to that. I want to mention both ways because I'm going to go back to the original variables in a moment. So having said that, this is u to the power of 1/2, and that uses the power rule, 1 over 1/2 plus 1 u to the power of 1/2 plus 1. Three halves. The reciprocal is 2/3. The product of these two is negative 1/3. And reverse substitution gives us negative 1/3, 25 minus x squared to the power of 3 halves, evaluated from 3 to 4. And I can go with original limits, and I'm done. However, what are the new limits? If I want to come up with the new limits, if I put 3 here, I get 9. 25 minus 9 is the lower limit 16. If I put 4 here, I get 16. 25 minus 16, the upper limit is 9. And that's what we are going to use. Plug in and keep the negative 1/3 out to make life easy. Square root of 9. 3 cubed 27 minus square root of 16. 4 cubed 64. 27 minus 64 is negative 37. The product of these two numbers is positive 37/3. The radius of a blood vessel is 1.4 millimeters. A drop causes the radius to change to 1.3 millimeters. It shrinks. Use differentials to find the approximate change in the area of a cross section of the vessel. So we have a cross section in a circular shape. It has some radius to begin with, r, which is of course 1.4. We know it to be 1.4. The drop causes it to shrink, so it becomes a smaller circle. So it has a different r, which is 1.3. Now the difference between the two, this much is dr, or delta r. So r is 1.4. dr is 1.3 minus 1.4, negative 0.1 millimeters. And area, we know the formula is pi r squared. We want to find dA. So this is dr, and we want to find, so r is 1.4, dr is negative 0.1, I is pi r squared. We want dA, which means approximate the shaded region, everybody. All right. So f prime is dy dx. I'm reminding you that means dy is f prime of x dx. So a prime is dA dr, which makes dA the product of these two. That's why I wrote that so you can see it. And we know area is pi r squared. So dA dr is a pi times what? Now, r squared gives you 2r, therefore 2 pi r. So having said that, dA is the same thing times dr. So this is 2 pi r, and dA is 2 pi r dr. Plug in. And 2 times 1.4 is 2.8 times negative 0.1 is negative 0.28. Keep the pi. So precisely negative 0.28 pi millimeters squared. You can put it into a calculator. It's an approximation. What does it mean? The area of the cross section of the vessel is decreasing by 0.28 pi millimeters squared. Notice the moment you say in decreasing, you don't have to mention the negative sign. What is the exact shaded region, which we call it delta A? The area of the smaller one, pi r squared, pi times 1.3 squared, minus this, the area of the larger one, pi r squared, pi times 1.4 squared. And that, as you can see, is very close to what we have here. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek. As seen in the diagram, find the maximum area. Always, if the drawing is not given, you come up with a drawing and define your variables. So here's the width, here's the length, here's the area. You want to maximize the area, which is x times y. We have 240 feet of fencing, so we have 1, 2, 3x, and only 1 y. This side doesn't need it. So 3x plus y must be 240. The methodology is very simple. You want this to be a function of one variable, but it's not. So what do? You solve for y here by moving the 3x, and you put it in here. So a becomes a of x equals x times 240 minus 3x. Now this is a function of one variable x, and x represents dimension must be positive, and it must be less than 80. Why is that? If you set this one equal to 0, x becomes 80. If you choose x to be larger than 80, this becomes negative. The product is negative. The area is negative. Cannot be. So now we want to find the critical point by finding a prime. And of course, if you distribute the x, it's easier to work with this. So what is a prime? 240 minus 6x. And we want to set it equal to 0, which results in critical point x equals 40. Now, what do we have here? We have an open interval of 0 to 80 with only one critical point. Local becomes absolute. That's the theory. So we can do the first or second derivative test. It's easier to go with the second. A double prime is minus 6. Remember, we just want the sign. You have to plug in, but it's independent of x, makes no difference. It's negative, means concave down, means maximum, because concave down looks like this. So the maximum occurs when x is 40. 3 times 40, 120, subtracted from 240, you get y is 120. Dimensions 40 by 120. Area is 4,800 square feet, everybody. I want you to see this side by side because any fraction you have to simplify it first. You notice this is 2, this is negative 3, so it's a very easy factoring. However, there's nothing you can do to factor the numerator. So for this one, the denominator is a choice of you. The derivative is the numerator. So the numerator times dx is du. We move the dx up, so it becomes clear we are dealing with the integral of du over u, which results in a natural log. And you replace the u, and that's the final answer. Now, notice they have identical denominators, but the numerator here is different. We can factor the 4 out, and that's the difference between the two. It simplifies. Any fractional format, you have to work with the simplified version only in its lowest term. Use the denominator. Its derivative is 2, which makes du equal to 2dx. And when you put this up here, you have 4 of them. Okay, so it's 2dx times 2. Okay, so again, I'm playing with the numbers. I need 2dx. Okay, 4 is 2 times 2. All right, so you rewrite it, and this part is just like this one, which gives you a natural log, and you replace the u, and you are done. 2 ln of absolute value of 2x plus 3 plus c. If I write the reciprocal of this one, I have to do long division. If I write the reciprocal of this one, I write the reciprocal of this one because they can simplify, and we end up with the following. Now, 2x over 4. This is half of x. This is 3/4. which means we no longer need substitution. This gives you half of x squared, with this becomes 1/4 x squared. This is 3/4 x and a constant, and we are done. So any fractional format, this cannot simplify, this can be must, and the reciprocal of this does not require substitution. G of x is half of x plus 3 for x less than -2, and x minus 1 for x larger than or equal to -2. Is G of x continuous at x equals -2? Why or why? First of all, why this question? If you look at this one, is a piecewise defined function. The top piece and the bottom piece are both linear functions. That means they are defined and continuous from negative to positive infinity. Therefore, this is continuous from negative infinity to -2. And this is continuous from -2 to infinity. Now, continuity has a specific definition. When the limit of f of x as x approaches a equals f of a, it becomes continuous at a. And that's what we are going to work on this. But what is the limit? One-sided limits. A function has a limit at a if the limit of f of x as x approaches a from the left equals L, and limit of f of x as x approaches a from the right is L, and therefore the limit of f of x as x approaches a equals L if one-sided limits become identical. So we start with the functional value, which means we're going to go with the equality. Use this function and plug in. We get -3. Left side less than, we're going to work with this one, and we're going to plug in, and we get 2. Right side limit larger than, we're going to work with this piece, and we get -3. As you can see, the left side and the right side, they don't have the same limit. Therefore, the limit does not exist. If the limit doesn't exist, the function cannot be continuous either. So the limit doesn't exist, and g is not continuous at x equals -2. However, is it continuous from the right? If you look at this value, the functional value, and this value, these two are identical. Therefore, we say it's continuous at x equals -2 from the right. Nevertheless, it is still discontinuous at x equals -2, so we don't want to mix them up. It doesn't change the fact that it's discontinuous. Reading graphs, making sure we can read graphs. We are interested in, given the graph of the function g, state the value. We are interested in the limit of g of x as x approaches 2. Notice from the left side, you're going this way, and you are moving towards this point. And this point has a y coordinate 3. From the right side, you're in this branch, you're moving towards this point, and this one has the y coordinate 1. Are they equal? No. The limit of g of x as x approaches d2, d and e does not exist. How about the limit of g of x as x approaches 5? We look at the one-sided limits as well. Notice, if I come from the left, I'm in this branch. From the right, I'm in this branch. Both of them will take us to this hole, and this hole has a y coordinate of 2, so they are identical, the limit exists. Nevertheless, the function is discontinuous at 2 as well as 5. Okay. Now, notice if we assume this is 1.4, it makes g of 5 at x equals 5 is equal to 1.4. Because it's not equal to 2, then it's not continuous. However, so because the definition of a continuity is the limit of f of x as x approaches a must be f of a, and it's not. G of x can be continuous at x equals 5 if what? Because this is a removable discontinuity, we can redefine the functional value instead of 1.4 to be equal to the limit. So if you redefine g of 5 to be 2, yes, it can be continuous. So it's a removable discontinuity. In other words, you can fix it. But this is a jump. Even g of 2 is not defined, but even if it's defined, you can't fix it. A jump can't be fixed. So this, there's nothing we can do. This one we can fix. We are given the graph and we want to find the following limits. So I'm going to remind you of VA, short for vertical asymptote. The limit of f of x as x approaches a, or a from the left or right, is negative or positive infinity, gives rise to the equation of a vertical asymptote x equals a. So for 2, we are approaching 2 from the left and right, negative infinity. It goes up to negative infinity. For 5, left and right takes us up to positive infinity. Now, what happens at -3 class, from the left takes us down to negative infinity. From the right takes us up to positive infinity. And to find VAs, this indicates x equals 2, this indicates x equals 5, this indicates x equals -3, this indicates the same thing. Therefore, the VAs equations x equals 2, x equals 5, x equals -3, those are the vertical asymptotes.